Okay, for this next video, we're going to solve a rational inequality. Remember I said that rational inequalities, you must first find the x-intercepts, the vertical asymptotes, and the wholes, because those are the three places that a graph can change sign. Okay, it can go from positive to negative or negative to positive. Once we find those, we're going to use a sign chart, just like we did before, and pick numbers in the intervals to determine which interval solves the inequality. Okay, so the example we're going to use is x plus 6 over x squared minus 9 is greater than or equal to 0. Okay, so again, the three things I need to find are the x-intercepts, vertical asymptotes, and wholes. So I'm going to start there. Actually, before I even go there, I need to factor and solve the numerator and denominator. Remember, the x-intercepts, vertical asymptotes, and wholes all come from the zeros of the numerator and the zeros of the denominator. So I'm going to take x plus 6, set it equal to 0, and solve. I get negative 6. If I take x squared minus 9, set it equal to 0, factor, and solve, I get positive 3 and negative 3. Okay, so these are the three zeros of the numerator and denominator. Remember, the x-intercepts come from the zeros of the top, the numerator only. So in that case, that would be negative 6. The vertical asymptotes come from zeros of the bottom only. Those would be the negative 3 and the 3. And then the wholes come from zeros of both. And in this case, there are none. Okay, there are no zeros of both. There's no overlap here. There's no number that occurs in both of these lists. Okay, so now I'm going to take these three numbers, put them into my sign chart. Now the sign chart is a little bit bigger. I need three numbers, negative 6, negative 3, and 3. The negative 6 is an x-intercept. That is going to be included no matter what. Well, yeah. And the other two are vertical asymptotes, and so the vertical asymptotes, I'm going to draw them in here like I would draw a vertical asymptote on a graph. Okay. And I'll explain a little bit more why I did that. Just it is a way to remember whether to use parentheses or brackets at the end. So I need a number in each of these three intervals. 0 is a nice one. I'm going to pop into that one interval there. I'll throw maybe we'll go 5 and negative 5 and negative 10, just because those are kind of nice numbers. And I'm going to plug those into my original rational function, except I'm going to use the factored form. So I'm going to plug them into the form x plus 6 over x plus 3, x minus 3. Okay, so we got these three factors. Let's go with the negative 10 first. Negative 10 plus 6 on top. Negative 10 plus 3 on the bottom. Negative 10 minus 3 on the bottom. The top is definitely negative. The bottom here, this is negative. And this one is negative, right? All three factors end up negative when you plug a negative 10 in. Three negatives make a negative answer. Okay. If I plug in the negative 5, I get negative 5 plus 6 over negative 5 plus 3 and negative 5 minus 3. That's definitely going to be a positive on top. A negative times a negative on the bottom. Double negative makes it positive. So the whole thing is positive. Oops, slide that over. Those are all positive outputs. If I then plug in the 0, I get 0 plus 6 over 0 plus 3 and 0 minus 3. That's going to be positive over a positive times, that's a negative. One negative will equal a negative, so these are all negative. And finally, with the 5, keep sliding this up, I get 5 plus 6 over 5 plus 3 and 5 minus 3. That's a positive on top. A positive times a positive on the bottom. And so that will give me a positive output. Okay. So our final answer needs to represent the original inequality, which was greater than, right? Rational function greater than 0, greater than our positive. So I'm looking for positive and positive intervals. So when I write my final answer out, I need the interval from -6 to -3, and the interval here from 3 to infinity. So I'm just going to write those out first. And now I got to figure out whether to put brackets or parentheses. Okay. The -6 is an x-intercept. The inequality has an equal sign. When those two things occur together, you need a bracket, because the function is equal to 0 at the x-intercept. But that's the only time it's equal to 0. Okay? At the asymptotes, the graph is not equal to 0. In fact, the graph doesn't even have a point there. So we can't include the asymptotes in the answer, ever. So asymptotes will always get a parenthesis, just like infinity also always gets a parenthesis. And then we'll write the union in between. Final solution then is the union of those two intervals, including the -6 and excluding the vertical asymptotes at -3 and 3.